Hello everyone and welcome to the last lecture of Applied Software Techniques. Today we will have a look at projectile-based movement, and together with that I also want to show you the concept of fake it till you make it, which is widely used in the gaming industry. So without further ado, let's head right into it. Let's take a last quick look at our current project progress. As I mentioned, we already finished the chess party, so our 3D chess game, and we also advanced into the physics-based dart handle part. You know now how this works, and today we will have a look at projectile-based collision, where we will actually fake everything we've learned the last time. Let's start this lecture with a very small recap. So what have we done the last time? You can see that's our dartboard here, and now everything works as we want. So when I press play, you can see I spawn in. I can pick a dart here, I can move around, and the dart moves with me. And now I can throw it, and it will actually stick on the dartboard. We can also take it out here. So let's take it out and throw again. And you can see it will still stick even if it doesn't hit the right target. Yeah, today we will have a look at the green darts and find out how we can implement the projectile-based movement. You can see currently I'm not able to pick them up. We will change that, and at the end of this lecture, we will actually be able to pick them up as well. So how did we implement that the last time? There were three parts which were relevant for us. First of all, we have a blueprint that's called BP_dart, and that is the parent object for all of our darts. Each of our dart has one of those colliders here, which are the relevant part for the physics or the collision handling. And once this collides with our dartboard, it will be stuck there. We implemented that in our second necessary part. So those two are the child objects. This one is the one which uses projectile movement, and this one uses physics only. And inside our content folder in the interactive media, no, not interactive media, but living room folder, then blueprints, and then living room character, we already added this logic here. And that allows us to, first of all, have two input actions. You might remember that already. We have that inside interactive media, darts input. Here we have our input actions, which we just had a look at, and also the input mapping context, which is activated inside our player controller. And then we can use this input action here and first of all start with finding a dart via ray tracing. Let's have a look at the function here. So what it does is it checks if we have a dart currently grabbed, and if this is not the case, so that's a variable with the variable type BP_dart, and if we don't have anything in our hand currently, then we create a raycast starting from our first person camera, the world location of our first camera. So imagine my eyes, I'm just looking at you. And then we have the forward vector, so the direction my eyes look, directly pointing towards you, multiplied by a grab range. So we have 200 in that case. And now we are able to reach 200 into the direction we are currently looking at. And we then add this together with our world location to create our endpoint. And we are drawing a ray right in our scene. And when this hits, we can actually open this up here. And you can see we have the hit actor. Then we get the class of this hit actor, and we can determine which dart class we want to search for. So in our case, in the event graph, we can just switch between our three classes here, and the two child classes here are the relevant ones for us. Then we check if this is true, and if it's true, we cast our hit actor to a BP_dart and set it as our grab dart. We also get our hit component, and we then give it outside the function back into the event graph, where we first of all check if our grab dart is now valid. And if that's the case, then we have a dart in our hand currently. We also check if our hit component is valid. That's the collider we want to use and we want then to pick up later on. And then we check if our grab dart, or actually the component, the collider component of our grab dart, has the constraint mode enabled here. And if it's not the case, we set this constraint mode to none anyway, because I just showed you that I have those darts added to the dartboard, but I locked them in X, Y, and Z direction, so they are not able to move around. I also disabled gravity, which we re-enable here to actually pick them up. And we set the collision enabled to physics only, so no Curie collision. And that's quite the tricky part of the last lecture, which of those we want to choose. In our case, it's physics only because we want to use a physics handle. And we then position our component object, which we get here, exactly at the location where this component is. And we pick up whatever is located there to our physics handle. You can see the function here, grab component at location with rotation, and then we have it mapped to our hand. To have it mapped over the whole time we're moving around, we have to check that inside the event tick function. And as you might remember, that is not very efficient. So when we have a grab dart, then we set the target location and rotation to a billboard component. We get the world transform of our billboard component and set our physics handle location and rotation to the billboard rotation and location. And what does this do? So when we have a look at our viewport, you can see this little dino here. And when I move around, you can see it's always facing towards me. And that's just how we can determine where the dart is currently facing. And what's also pretty cool, if I move a little bit faster, it rotates not directly with me, but a little bit later on. So it looks like it's moving very smoothly left and right. So that's why we use this one for our target location and rotation. To then throw a dart, we have the following function. So we have our enhanced input event, which is the throw event. Then we check if our grab dart is valid. And if this is the case, we do once a check for the class of this dart. And if it's a dart physics, then we go on here. Otherwise, we just reset it. So the next time we call this input action here, we can check again if it's now the correct class. Let's go on with the true path. So we have a dart physics here. Then we release the component. So we don't have a physics handle anymore. And then we get the grabbed dart and the collider component from that. Set the collision to Curie and physics so we can actually collide with the dartboard. And then we set the linear damping to 0.01 so the dart can actually move quite fast in the forward direction. And then we apply an impulse at the position where we have our first-person camera into the direction of the forward vector. So in my case, we have a throw power of 2500, as you can see down here. And this throw power allows us to launch this dart right into the direction I'm currently looking, so right towards you, with the throw power of 2500. And then we just make sure that we set the grab dart to none, because we have none in our hand anymore, because it's just flying through the room. And then we reset everything here, so the next time we throw, we can actually check if our grab dart is of type dart physics again. The last part, which I mentioned, is the dart part. So inside the interactive media darts folder, we have our darts physics, and we added something when we hit something with our collider. And we just check if the other actor is a dart cabinet, that's the name of the dartboard. And if this is the case, then we go into this branch here and we go and change the linear damping and angular damping of our collider and set it to a ridiculously high amount. So it's basically stuck wherever it lands. And we call the hit by physics dart in the string logic so we can just see what actually hit our dartboard. As I mentioned before, we already built this part up here. That's the physics part from the last lecture. But today we want to focus on the green part down here, where I want to show you the fake it till you make it approach, which is widely used in the gaming industry. And how can we do that? So first of all, it's best if we start with our grabbing logic again. So simply right click and enter grab in here. Then we call the enhanced input action IA grab again. And we also have our grab dart now down here in our variables. You can see that. And I can just simply drag and drop it in here. So let's do that. From there, we first of all check if it's valid again. So nothing special about that. And then we go and drag out our function find dart via ray tracing. And if we don't have a valid dart in our hand, we want to search for one. So in our case, we go with the dart class to find, and that's a dart projectile in this case. And now we have the same logic as before, but this time a little bit different. First of all, we only have to check for grab dart. So get our grab dart and check if it's now valid. All right. And from there, we can call the set actor hidden in game event, which you already know from the chess game. So set actor hidden in game. And we want to hide the dart. So what does it do now? We grab this dart, and then instead of actually taking it physically correct to our hand, we actually just pretend to do so by disabling the vision of this dart and then spawning it instead as a projectile once we throw it. So the next part we have to do is we have a dart dummy up here. And how does this look like? I can quickly show that to you. So here we have our dart dummy. And this dart dummy, let's quickly disable the billboard, otherwise we won't see it, I guess. Let's say visible force. Here you can see there is a dart located right in front of our camera. And that's exactly how it will look like once we activate the dart dummy. So that's just a mesh which is located in front of our face, and we can then throw not actually the dart, but we can just disable the mesh again, and then we can spawn a projectile instead of throwing an actual dart. So let's go back to our event graph. Now we pick our dart dummy here, and we set it to set hidden in game. Set hidden in game. And we want to have that set to be false because now we want to see it. So that's the whole logic for the grabbing part. Let's quickly wrap it up. Nothing special here. The tricky part will come in the collision this time. So we check if our grab dart is not valid, so we don't have anything in our hand. Then we search for a dart class to find, the dart projectile in our case. Then we have our out hit component, which we don't need in this case. And then we check if our grab dart is valid. If that's the case, we set it hidden, so it just disappears from our screen, and we activate the dart dummy, so we can actually have this view here, and we can see that we are ready to throw the dart. The next part is, of course, the throwing logic. So simply right-click again, pick, throw, and you will find this enhanced action event. Just pick that, and from there we want to do now something special. First of all, we want to get our grab dart again and check if it's valid. What's that for? Simply because we want to check if we have something in our hand, otherwise we won't throw anything. Then we go into our do once again. Do once. You already know what this does. And we also get our class from here. So get class. And if this class now equals our dart projectile, so simply enter projectile here, that should find your dart. Yeah, right here we have it, dart projectile. And we then check if that's the case by using a branch. So if we have a dart projectile, we want to go on here. Otherwise, we want to reset everything so we can try to throw the dart again once we haven't succeeded throwing it. All right, from the true part, we now get the dart dummy. So the dart dummy is used to, first of all, set hidden in game. We want to set it hidden again. So in this case, we don't have the problem that it is in front of our face anymore. And we also want to get the world transform of it to spawn our projectile at this location. Split the value up here by hovering over it, right-clicking, split struct pin, and from there, we then want to spawn an actor, which is a BP spawn actor from class, and that's a BP dart projectile. So enter dart here and go with BP dart projectile. Now we want to also split up the spawn transform. So we simply split that up and use the transform location, transform rotation, and not descale. We just want it to spawn default. And now we want to pick our collision handling override. You already know that from the chess as well. And we want to have always spawn ignore collisions. So now that will spawn our dart projectile in front of us. And from there, we want to destroy our grab dart now. So let's quickly get this grab dart. That's still located at our dartboard, but it's not visible. And now we want to destroy it. So we simply destroy our actor. And then we say our grab dart is null again because we don't have anything in our hand. And from there, we just connect the false path of our branch and we put it up here. So we're good to go. Let's quickly do a wrap up here as well. So we check if we have a grab dart in our hand. If we have, we check once if we have the right class. If it's a dart projectile, then we go on here. If it's false, we can do it again. So next time we want to throw, we can try again. And then we have our dart dummy. That's just this thing, which is in front of our camera. So it looks like we have something in our hand. And then we set it hidden in game. Yeah, we want to hide it again because nothing is in front of our camera anymore. Then we get the world transform of our dart dummy. So the location and rotation. And we spawn a dart projectile at the location of our dart dummy. Then we destroy our grab dart, which is currently still located at the dartboard, just not visible at all. And then we set our grab dart back to 0 or null. So we actually ensure that nothing is in our hand anymore. So how does this look like now? Let's have a quick look. When we go into our game now, you can see we can pick up this dart. And instead of wiggling around like it was with the physics part, we now have it locked in a certain position. And when we throw it now, you can see it flies right through our dartboard. So why is this the case? Yeah, well, there's something different with a projectile. Of course, we have to check for collision, and we'll do that now. That's going to be the tricky part now. But let's quickly have a look at how we can actually set that up. So when we go into our content drawer, and now we go onto the content, interactive media, darts, blueprints folder, and then we go to dart projectile, you can see we have a projectile movement here. And how can we set it up now that actually everything is happening correctly? So here we have to switch between non-physics and physics, and that's quite a lot more tricky than the other option. But instead, we have here the option to not using event tick, so we don't have to adjust the location of our dart arrow every time, but instead we can just fake it in front of our camera and then throw it based on a projectile. So how does this dart even fly? We have a projectile movement in here, and this projectile movement has something called initial speed and max speed. So that is how fast you want to throw the projectile. So once it spawns, it has a certain velocity and it will fly directly into the direction it was spawned in. We can also go a little bit further down. I enabled simulation here. I swapped the collision and I didn't tick homing projectile here. If you want to have a homing projectile, so it actually follows a player or something, you just have to tick that and you have to tell how part, it should follow the player. So for example, it should not move out too fast. So if you go with 0, it will just try to find its own way. If not, it will follow very, very, very exact the path of the player until it hits him. Here we have the velocity. I just set the velocity to 1000 in x direction. So you can see that here. And now it just flies straight in front of me. And that's why the dart is spawned there and then flies towards you in my example when I look at you. Yeah. So that's it. And now you can see we don't have anything inside of here which I can actually tick differently. I could decide a bounce of a projectile, so you can actually decide how often a projectile should bounce before it gets deleted. And yeah, some stuff like this you can install here, or you can set the projectile gravity scale. So if it has to work with a different gravity scale, so it should be more stable than our dart in our case, for example, you can pull that up or down as you wish. Inside our collider part, we now have the physics disabled, as you can see here. We don't have any constraints. That's why we didn't reset them. And we now have something set here, which is nothing special, but instead we have now our hit events and overlap events set to enabled and the collision preset set to custom. So the collision enabled is here Fury and physics, and we block the visibility and camera. We just use world static here. And I don't want to overlap or block with my pawn because the dart will be spawned right in front of my face, and it's very likely to collide with myself because I'm the pawn in this case. And that's why I set it to ignore here. We also use CCD again, so continuous collision detection. And we also use true motion aware collision detection. That's especially useful for bullets. Yeah, so that's the part here. Now add event again, and we can do that simply by clicking onto the on component begin overlap part here. We don't want to have the hit part because that's relevant later on. And instead we go with begin overlap. So simply click onto the plus here, and here we go. All right. From there, we now first of all want to cast our other actor to a dart cabinet. That's nothing that we don't know, so that is the same as the last time. But we also want to check if we don't have interfered with ourselves. So if the dart interferes with itself, it will also be stuck in the air and won't move anymore. So in this case, we have to also make sure that we are not equal. So just do the exclamation mark equals, not equal. And now we want to check if we are not ourselves. So just pull that out and get a reference to self. If the other actor is not ourselves, then we have this cast failed part here, but I just want to show that to you later on. And now we go on and set the collider physics and yeah, collision and so on. So quickly pull your collider out of here. From there, we first of all want to set a collision profile name. We can simply use that one here, set collision profile name, and we only do that if we hit the dart cabinet. And then we want to call the profile name, and now you have to make sure that it's exactly written correctly. So physics actor, that's the profile name we want, and we want to update the overlaps. That's the one we set also for the physics dart. So what we want to do now is once it overlaps the dartboard, we want to set the collision physics base because that's the best collision result we can get. And thus we select physics actor instead of what we had before. And that was just, let me have a look at that. We had before our world static collision. Yeah. So that's basically what we changed here. We just switched to physics actor, this profile name here, instead of the collision enabled section or custom what I just enabled here. From there, we now want to set the collision response to all channels. So set collision responds to all channels of the collider. We don't need this collider part here. We can simply work with the one we already have. And what do we want to set here? That's the block response, because we want everything to block us now. So in case we hit a dartboard, we then want to be stopped once we hit it again. Not overlapping, but once we overlap, we want to then switch to the hit event to actually determine where did we hit the dartboard. The last part we have to do is that we set the collider to simulate physics, so set simulate physics. And that needs to be set to true in this case, otherwise we won't be able to detect a collision. All right, the next part is what happens if we don't hit a dartboard. In that case, we want to have the cast to be failed. We want to go into a branch. And if we didn't hit the dart cabinet, then we first of all have to make sure that we didn't hit ourselves. So simply connect those two. And from there, we want to set our collider logic as well as the upper part. So let's quickly get this part here. Also with the collider, like this, right? And now we just copy and paste it down here. And from there, we want to have the physics actor, we want the new response to block, and we also want to have simulate physics. But we also want one more, and that is we want to set enable gravity. So set enable gravity for our collider. And that should be set to true as well, because it should, once it hits a wall, for example, it should just fall down instead of moving through it. So that's how we can ensure that everything that collides with or overlaps with anything is then set to a physics-based collision afterwards. And that can be done then using the onComponent hit function. So go to the collider again. Go down as far as you can. And here we have our events again. So this time we want to have onComponent hit. Just click onto the plus and get this event in here. And now what we want to do is we want to cast the other actor to a dart cabinet again. And from the dart cabinet, we want to get our projectile movement. And this projectile movement should then stop the movement immediately. So the projectile doesn't move any further. And for our collider, we now want to set the same thing as last time. We want to set our linear damping and our angular damping to a ridiculously high amount, so the dart actually gets stuck in our dartboard. Let's quickly add that. So drag out from the collider, set linear damping. Here we go. Set a ridiculously high amount, so something like this is fine. And also make sure to set angular damping pretty accurately, right? And now we can see that we have set everything up. Don't forget to set the damping for the angular as well to a ridiculously high amount. And with that, we can then call a print function. So we simply call print string. And we want to tell our dartboard that it got hit by a projectile dart. Like this. All right, let's quickly wrap that up again. I know this is quite tricky, but you don't have the part of the event tick in here, which makes it way more efficient, because have a look at our living room character again. What we have here is the only thing we do once we grabbed our dart is to disable its visual and to activate the dart dummy in front of our eye. Once we throw it, we just check for it, then set the dart in front of our eye hidden in game, spawn a projectile in front of us, and we don't care about anything until it hits something. Then we switch to our dart projectile here. And the first thing we have to do here is to make sure that we have the onComponent begin overlap. So once it overlaps with the dartboard, we want to enable the physics-based collision. And that can be done like this. We cast to a dart cabinet, we set our collision to physics actor, and update on overlaps. We want it to be blocked once we hit something that's blocking a physics actor. And then we set simulate physics to actually get a collision on the hit event. You can't use the hit event without enabling physics, so that's why we do that here. The other part is if we hit a wall, for example, we check if we didn't collide with ourselves. So the dart can also collide with itself, of course. So for example, once it hits another dart, which is already stuck in the dartboard. Yeah. And then we have the collider function here. Then when we didn't hit the dart cabinet and we didn't hit ourselves, we set our profile dynamic as well to physics actor, update on overlaps, block the collision response on all channels, and set simulate physics. But we also want to have gravity enabled, so we just bounce from the wall and fall down to the ground. And here we have then the component hit. So that's two different parts. Once we overlap, we then want to have the hit detection enabled. So if we hit the dart cabinet, then we stop our projectile movement immediately. That wouldn't make our dart stuck at that position already because we enabled physics. But we also set our damping to a ridiculously high amount, and that's how it gets stuck in the dartboard once again. Let's quickly check that if everything works as intended. So we go into the play part here. We can now pick up this dart. You can see it's hovering in front of me. It's not bugging around, and once I throw it, it will hit the dartboard just as the other did as well. What you see here is a little bit of a problem that's physics-based. So if the dart doesn't hit the board correctly, that's also happening with those here, then it might be stuck like that. So that's why you could also add a constraint here. So lock the X, Y, and Z coordinates once it hits the dartboard to make sure that this doesn't happen. Now we can throw another one, and you can see it only happens sometimes. It's not really clear when this happens, but we can get rid of it if we set a constraint as well. Of course, now the question arises, how often does this happen? And what can we do about it? And the big problem is that's physics-based. So it's quite hard to fix that. But we cannot just pick up a dart here and then throw it. But instead, I also provided you with a darts gun. And when we move very closely to it, it will be just picked up. And now we can move with the gun towards the dartboard to actually see how bad it is. And let's quickly deactivate my sound here because otherwise there will be quite a pain experience. And let's just shoot some there. And what you can see is that's not exactly what we expect, is it? So there's some of the darts are just hitting the board correctly, but others completely don't. For example, have a look at this dart here. That's not what we want. And the big problem is we can't fix it because it's physics-based collision. And whenever you're not able to control something by your own, just fake it. So what we'll do now is instead of actually having a dart projectile hitting here, we will just spawn in a constrained dart that looks like a dart projectile, but is not a dart projectile. So it has no movement and so on. It will just spawn at the right position. And to do that, we can go on and go into our content drawer. And inside the dart projectile part, we now have to get rid of this part here first. So simply delete that. And the first thing we want to do after we've checked that we hit a dart cabinet is we want to get our collider and destroy this component. So simply call destroy component. And then we want to spawn in another actor. So we just drag out from here, we spawn actor from class, and we don't select the class yet, but we just compile, and you can see we get an error because we have no class specified and we haven't set a transform yet. So for the transform, we just split our struct pin And where do we get the location now? So the good thing is the hit already provides that to us. So we can just click onto the hit with the right click and then call split struct pin. And here we have our hit location. So that's our spawn transform location. And now we have to also get a rotation to spawn our dart in. Otherwise, it will just be sticking directly into the dartboard, and that's not what we want. And to get that, we want the actual rotation of ourselves. So we can just call get actor rotation. Here, get actor rotation, and just drag and drop it in here and connect it. So now what about the glass? First, let's finish that. So then we want to print our string. And afterwards, we want to destroy our actor just to ensure that it doesn't fly endlessly. Because what happens when we destroy the collider component? Yeah, we have nothing physics-based anymore. So we can't get blocked and we can't be provided from spawning. But to ensure that a little bit more, we can also set the collision handling override here to always spawn and ignore collisions. And now we have to create a new class. This new class will be created inside the content drawer. So just go to the content drawer. You can see the dart projectile isn't here anymore because we have an error in here. But let's quickly duplicate that. Just right click onto it, call duplicate, and name it BP Dart Projectile Dummy. Let's go into that. And here, first of all, we want to get rid of all of the movement parts. So no collision check anymore. Then we delete the projectile movement as well. And inside the collider, we want to do two things. First of all, scroll down until you find the simulate physics part and lock the position and rotation completely. So activate all of that just to ensure that it is not able to move once it is spawned. We also made sure that it doesn't fly itself because we deleted the projectile movement part here. So in this case, we can just ensure everything is working. But one more problem arises, and you can see our dart is spawned here. So it would just be stuck halfway through the dartboard, and that's not what we want. So to fix that, we can go onto the collider again and just go back here by -7. So now we would spawn with this position here. So right at the tip of our dart. And that's exactly what we want. So now we have our dart projectile set up. And now we can go back to the dart projectile itself, not the dart projectile dummy anymore. And select our class here. And that should be a dart projectile dummy. And now if we compile and save, everything should work. All right. The big problem now is that we don't have any dart projectile dummy at the moment, right? So we just spawn it once we hit something with our collider. So let's quickly wrap that up again. Once we hit something with our collider, we cast the other actor to a dart cabinet. And if it's a dart cabinet, we destroy our own component, our own collider, because then we have nothing physics-based anymore. We spawn in a dart projectile dummy, which is constrained in all directions, so it can't move, rotate, and so on. And we also print our string afterwards and then destroy the projectile dart because we have now replaced it by this dart projectile dummy. That's not all we have to do. We also have to ensure that it's working with the right thing from the start. So let's go back to our scene. And now the question arises, how can we actually replace these actors the best way? And yeah, we have our dart projectile here. And we don't want a dart projectile here anymore. We want a dart projectile dummy here. So what can we do about that? The good thing is Unreal Engine offers us a function for that. So we simply right click here and then we can call replace selected actors with, and now we have dart projectile dummy here. So why is this the case? So if we go to content drawer and for example click onto dart physics and now right click again onto the dart projectile. What was it? Let's just take this one. That should work fine. And then we go on to replace selected actors with. You can see I can select it, or I can replace it with the selected part inside my content drawer. So we don't want to replace it by Dart Physics, but instead with Dart Projectile dummy. So we simply click onto here. There we go into Dart Projectile and call replace selected actors with. And now we click onto the selection part here, and you can see it just replaces this actor for us, and it's now no longer a Dart Projectile, but a Dart Projectile dummy. Let's quickly do that with all of those. So we click onto here, replace selected actors with, and then we go with the selection part here. Next part, Dart Projectile dummy. Next one, Dart Projectile dummy. Replace selected actors with, and we go again, replace Dart Projectile dummy. So the last thing we have to do is to make them move a little bit further down. So let's quickly do that as well. And for this, we can just either have a look at here and just set it to 171, for example, then it will be just as before. And that's just how we can replace our darts here to make the logic work differently. The next problem which arises is, of course, that we are not able to detect our Dart Projectile dummies inside our living room character. And that's back inside the content folder. When we go to living room, blueprints, living room character, you can see what we check here for is a Dart Projectile, not a Dart Projectile dummy. And that's quite tricky because we have two things now. We can have a Dart Projectile dummy when we hit the dartboard, but if we don't hit the dartboard, just have a quick look at here, we don't spawn in something else, and we just want to have gravity enabled and simulate physics, so the actual dart bounces off our wall, for example. And just in case we hit a dart cabinet, we want it to be spawned in, but with constraints. And since this is not that simple, we have to also adjust something in our living room character. And that's inside the find dart via ray tracing part, because we now need not only a dart projectile here, but instead an array of darts. And we also want dart projectile here to be checked. So what we can do is find dart via ray tracing. Then we go to the Dart class to find and simply change our class here. BP Dart is fine. Let's call Dart classes to find instead. And we just make an array out of here instead of a single one. And now if we compile again, you can see we have one big problem here, and that's this part here. It isn't known any longer. And we can also not check if it is equal to an array. So in this case, we just have to get rid of this node as well. And now what we can do is to call contains, and we call the utilities function array contains item. And now what we can do is we can just search for our Dart classes to find. And with that, we can now check if our array contains the Dart class we want to find. Now we have a problem, but that's not inside of here, but instead we have the problem outside, and that's inside the event graph. You can see now there's no longer this node anymore. So we have to get rid of that. So simply hold down the Alt key and delete it. And we also have the big problem here that we are not able to find this part anymore. So let's delete this as well. And now for the ray tracing part of the physics-based Dart, we want to set a specific array. So we simply call promote to variable. Now we call this physics Dart classes. And what's cool now, if we compile that, you can already see we now have the option to set our array elements here. And if we click onto the plus, we can simply select from our drop-down menu, because those are all the child classes referring to BP Dart. So now we can just click onto Dart Physics, compile and save, and that fixes the first issue here for us. We don't have to change that because we just want to check for Dart Physics. But in this case, we want to have a different array. So simply click onto promote to variable. Now this spawns right inside my node. Cool. Let's move it down. And now rename that to projectile dart classes. Now we need to recompile it again. And from here, we have to check our projectile dart classes. And that should just be inside of here. So we simply click onto the plus. We select Dart Projectile, and we also click onto another plus here and add Dart Projectile dummy here. So now we are able to trace for both of them. Great. We still have a problem, so let's quickly check that. Okay, this get class return value doesn't work anymore. But we can try again if we simply get our class again, and now everything should work as intended when we delete this node again. So let's try that. Contains item. All right. We're not able to do that here because we haven't casted it to Dart. So let's do a quick cast. So we go up here, cast to, or let's cast it to a Dart. BP Dart is, yeah, here, right, we have it here. And now we can ensure that it's a Dart, and now we should be able to use the contains option of the array. And with that, we don't get the class of the hit actor, but ensure that it's a Dart class. And from there, we just get the class. I have to move everything here back a little bit. Let's quickly do that as well. Right? And with the contains part here, we are now able to drag and drop it in here, and that should fix our problem with the contains part. Now we combine the condition with this here. I will just move it a little bit out again so it looks a little bit nicer. And yeah, now we have our check for the Dart classes defined. Now we can ensure that it is inside our array and don't have any problems with detecting it anymore. So the last thing we have to do is, of course, for the grab event here, we don't want to just check for the projectile dart classes here. But of course, we could also have a grab dart now of the class dart projectile dummy. And to check also this part, we just have to delete this section here. So inside this row event, and instead get our projectile dart classes. And now we search instead of checking if it's inside of there for contains item. And then we simply combine those two. And now everything should work as we want. So what's happening now? Let's quickly wrap it up again. First of all, we check for a grab dart. And if we have one in our hand, that's totally fine. Then we don't do anything. If we don't have anything in our hand, then we go and check our projectile dart classes. And we search for both dart projectile and dart projectile dummy. And if we then have a valid grab dart afterwards, we set it to hidden and our dart dummy in front of our camera to activate it. So it's not hidden anymore. For the throw event, we now don't check for one class, but for two classes. So if we have a grab dart that is valid, and it's of the classes we specified inside our array here, then we go on and set the dart dummy hidden in game and spawn a dart projectile at the position of our dart dummy in front of our face. And that's also quite a relevant part. Our dart dummy, as you can see here, has no collision set, because otherwise we would interfere with the spawning of our dart projectile. And then once this is spawned, we just destroy the grab dart we had in our hand, or not the grab dart we had in our hand, but the dart was still located at the dartboard. And then we destroy the actor which is located there. It was just invisible before. And then we reset our grab dart to none. Yeah, so that's how it works in here. Then the dart flies because it's a projectile. And when we go into the dart projectile part, once we hit a dart cabinet, we set the collision to physics actor so we can check it physics-based. Then we call the new response to be blocked and the simulate physics to be true. That's just so we are able to get this on component hit down here. And once we hit the dart cabinet, actually then we destroy the collider component just to ensure that non-physics-based stuff is happening anymore. We get our actor rotation and we spawn a dart projectile dummy at our hit location. Then we simply print a string and destroy our actor so it doesn't fly endlessly through our scene. So why those two classes? Because otherwise, if we don't have that, when we fail our cast, so we didn't hit a dart cabinet and we aren't ourselves, so we didn't interfere with ourselves as the dart here, then we just set the collider to physics actor, block, and simulate. But we also enable the gravity so it just bounces off the wall. And let's quickly check how all of that looks together. So now if we go to our dartboard and take our dart, you can see nothing changed. It's just working as before. But when I take my gun now and I shoot, you can see all of the darts are sticking perfectly into the dartboard. And that's just because we faked it instead of actual doing the physics collision-based stuff. Yeah, so that's the big part of fake it till you make it. Just so we've spoken about everything, I want to show you how I implemented this weapon inside the game. And that's not quite tricky. So when you go to the content drawer, you see this folder standard first person. And you can simply add that by clicking onto the add feature or content pack after you clicked onto the plus here. And yet now you can see I can just add the Unreal Engine content to the project by clicking onto it. And what I added is this first person part, which, as you can see, already includes such a weapon. And now I just duplicated that inside our interactive media folder. And now inside the darts folder, here is our arrow rifle. That comes together with a dart weapon component. I will show that to you in a second. But let's click onto the arrow rifle. So how can we pick that up? You can see it just looks like this. So if we actually collide with this sphere here, or if we overlap with that sphere, we will get this weapon in our hand. And that's exactly how you can get this weapon from the shelf. It's also because you collided with this sphere here, the sphere collision. And now we have this on component begin overlap sphere collision. We check if we are a living room character. And if that's the case, we set our character reference. And then, first of all, set that the character doesn't have a weapon. Then inside our first person mesh, we get children components. So what's that? In our living room character, we have our mesh here. And this mesh could have child components. So for example, a weapon component. If I click onto the plus here and now add weapon, you can see there are two components. And in our case, that would be the dart weapon component. So it simply would look like this. And now our mesh has this weapon down here added to it. So let's get quickly rid of that again. Inside the arrow rifle, that's what we check here for. So if it has any children components, and in our case, you can see the mesh doesn't have any. Now we loop over them. And if one of those array elements is actually a dart weapon component, we call set character has weapon, because then, of course, he has one. Then we check for if the character has a weapon now. And if it's false, we add the start weapon component to our character reference. You can see that here. So we just get our character reference there. And then destroy our actor. So what that does is, once we overlap with the sphere here, we check if we are a living room character and then iterate over the mesh components. So these mesh components here for our character. And if there is already a dart weapon component, we don't need to add it because he already has a rifle in his hand. Otherwise, he doesn't, and we just add one and then destroy this pickup actor here so we can actually have the gun in our hand. The other part is, what does the dart weapon component do now? So the dart weapon component does a lot more. So on begin play, we try to get the owner, and if we are a living room character, we attach our component to a specific component, and that's called a socket name grip point. So what's that? That's the next part, which is quite tricky to understand. But inside our living room character and our mesh here, we have so-called mesh parent sockets. And let me see where this is located in. When we go onto our skeletal mesh here, which currently is not, oh, right here, the first person mesh, my bad. Here we have it. And inside this skeletal mesh, we have our bones. And as you can see, we have quite a lot of stuff in here. But we also have something that's called a grip point. And this grip point is located here, as you can see. So that's a skeletal mesh. Maybe I need to talk about that a little bit in detail as well. So how does our character actually look like? You can see our character looks like this. And now you have the different bones in here. And those different bones allow us to actually turn our character based on this bone. So in this case, we just want to add our weapon to the grip point here. And with that grip point, we can now turn around and just place the weapon in our hand as we need it to. So with this dart weapon component, that's the first thing we do. So we add our weapon to this grip point here and call snap to target, so it just fits in there. Afterwards, we get our player character controller and enhance our input local player subsystem to IMC underline weapons. So what are we doing here? Now we get into the core essence, and I know that's actually advanced stuff. So I just want to show it to you. Don't worry if you don't understand it at the first time. That's how we can, or no, that's all the input actions our player is able to do. And now we just add some to them. So if we have one already and our enhanced input local player subsystem is valid, we just want to add a mapping context, and that's the mapping context IMC weapons. You can see here we have also our living room mapping context, but we want to have this IMC weapons. Let's quickly check what that is. So go to content, search for IMC, and here we have our IMC weapons part. Let's quickly have a look at it. And there's an IA shoot. So on the left mouse button, we can actually shoot. And we can also drop our weapon. That's something I added here. You can drop your weapon clicking onto left shift, then it's gone from your hand. And that's just another input action. So let's quickly have a look at the IA underline. You can see I just implemented a drop weapon here. And that's just inside the triggers. I also used pressed. So once you press the shift key, you will get rid of your weapon if you have one. And for the shoot, that's actually from Unreal Engine itself. It's also on the left mouse button pressed. So that's how we can shoot and drop our weapon. So that's the context we just add to our dart weapon component here. Or actually our local player input subsystem. And from there, we then call the anim instance. And that's something I also have to explain, because our character's first person mesh has a so-called anim instance. And that means an animation instance. You can see that here, that's the animation class we have up here. And we can simply change that. So let's quickly search for BPA underline living room character. BPA underline living room character. I can tell you where it is located. It's also inside the content folder. So interactive media, darts, and here we have our BPA living room character. So that's our animation system. And what we do first is we have this blueprint update animation. We try to get our pawn owner. And if we have a valid pawn owner, we just do first of all, check if we are in air. So we get our pawn owner, and from there we get our movement component and check if is falling is true. And if it is correct, then our player is set to be in air. Then we also have the second part where we check if he's currently moving. So that's based on his velocity. We simply turn the velocity into a vector length, and then we check if it's bigger than 1 and 0. And if this is the case, we have a moving character in front of us. You can also see we have the variables down here. So is moving as an air and has rifle. We can also check that in here. So that would then change our behavior of the animation system. And now the last part, which might be interesting. So what's the locomotion system? Let's quickly check that. So inside our animation graph, we have two options here. We have the locomotion state machine and we have the locomotion rifle state machine. So let's quickly click onto locomotion state machine. You can see currently we are in the idle state. And from there, we can either go to run and then go back to idle. We can go from idle to jump start, then jump loop, and then jump end. So what does this do here? You have to understand that this is a combination of different animations, and that's just how we can call them after each other. So in this case, we can go from idle to run. We can go from run to jump start. We can go from idle to jump start. And if we have triggered the jump start, we can go to jump loop, jump end, and then back to idle. So that's our locomotion state if we don't have a weapon. And if we have a weapon, you can see it's basically completely the same, but this will be activated if we have a weapon in our hand instead of this locomotion state machine. So you would be able to change that very easily. One more thing to mention here is how we actually switch between the states, and let's quickly have a look at that. So when I hover over here, you can see that we get from the idle to the jump start mode when the Boolean is in air is set to true. Then inside the jump loop, we check if the asset player time from end is smaller or equal to 0.1. And from there, when we are not in the air anymore, we will call jump end and then go back to the idle mode once the instance asset player time from end is smaller or equal to 0.1 again. Inside the idle to run path, we have the is moving Boolean variable, which is deciding in which state we go. And if we're not moving anymore, then we are going back to idle from the running state. The last thing we can check is this part here. So we go from running to jump start once the Boolean is in air is activated. So that's the way we can go here. We can also check that very quickly for the rifle state. So from the idle, we can get by Boolean is in air. Same as here is moving and is moving. Down we have Boolean is in air. Here we check for something else. We check for the first person rifle jump asset, which should be equal or smaller than 0.1. And then we have the Boolean is in air. When this is not the case anymore, we trigger jump end, and then we check if our rifle land asset is smaller or equal to 0.1, then we go back to the idle state. The last thing we have to check for is how does our animations work? And you can see you have different tabs up here. So if you go onto this tab, for example, you are inside your bones, where you can just turn something around and twist the lower arm, for example. Then we have our skeletal mesh. That's what we already know, where we can change our grip point based on the bones. And now we also have something called shooting montage, for example. So that's just what will be played when we actually fire our rifle. So we get this little knockback, which you normally get when you trigger a weapon. But we also have different other options here. So have a look at the falling animation. We can activate that by pressing the space bar. And you can see that's how we look when we fall. We can have the idle, that's the idle animation. We have the jump, we have the land, we have the rifle jump, and so on. We also have the rifle shoot montage, which is this knockback here. The run forward looks like this. And those are the animations which we can set. Unreal Engine offers us a little more, and that's quite cool because what you could actually do is if we go onto our meshes, so our player mesh here, let's quickly do that. So let's get a motion system for what's it called? Like it's inside of animation. And then we have the animation blueprint here. So, no, sorry, blend space. That's what I was searching for. And if I now take our mannequin arm skeleton, I can just create a new blend space. Let's quickly show you what this does for us. You can see there's one value here. And what's pretty cool is if you just want a very, very easy animation in Unreal Engine, you can use this blend space. And that's working by simply dragging and dropping some stuff like this in here. So for example, you can just set it here. Then you can decide what value you want to have. So in my case, I want to have 50 and 0. And now if I just put another animation here, it will just automatically blend between those two. And I can just set that. Let's quickly set that to 50 as well. And now what's happening? You can see my animation will blend in a second. So have a look at this. Hold down the control key and now you will be able to move up and you can just smoothly blend between those two animations by simply going up and down. And what's pretty cool about that, that's how you can easily, let's say, maneuver your player through the scene. So if you want to have something that is, for example, blending between very slow movement and getting faster, you can just set this value from outside very, very easily. And then you can just blend your animations like this. You can also add a jump in there. So for example, if I go with the first person jump here and I go down a little, you can see it will look like I'm jumping a little. And from idle into jump looks like this. And then we just start to run. So it will try to smoothly blend your animations. And you can also add, for example, left and right if you want to have one more part. So this one is currently called none. We could just set something here, or we actually name it. So in my case, I would name that, for example, speed. And then you will see that speed pops up here on the horizontal axis. So that's of course not correct. I want to have it here. Speed. Now this is called speed. And we just change the horizontal axis to, for example, direction. And now you could imagine what's happening here. So if I now maneuver my cross here around, I can just blend my animations from moving straight forward to turning left, turning right, and so on. And it will just look so good in here. That's my most favorite part about animations in Unreal Engine. Yeah, right. So with that being said, let's get rid of this part again. And let's go back to our Dart weapon component because we still haven't done that yet. So inside our getAnim instance, we can now cast to a living room character and set inside our BPA living room character, which is this part here. This variable down here has rifle to be true, and then it behaves differently. So that's what's happening inside this event graph in the upper part. The other option or the other action which can be triggered is the shooting action. Let's quickly have a look at that as well. So this skeletal mesh part here is not relevant, I think. No, it isn't. So first of all, we get our player camera, get our camera rotation. get our projectile offset, which is just set here. So that's where our projectile will be spawned, 100 in front of us and -10 under us, or under the weapon, so it doesn't look like it's not coming from the weapon directly. Then we add our socket location, so where the ammo is, plus the position from our camera plus the projectile offset. And then we make a transform out of that. That's the location we use for this. And we get the camera rotation to actually get the spawn transform then. And from there, we spawn the actor dart projectile, which then plays a sound. That's just first person template weapon fire. And then we go to our character first person mesh. Inside the anim instance, we call the montage to play, which is this FP rifle shoot. And that's then this knockback which the character gets when he shoots the weapon. So that's what's happening inside our dart weapon component. And yeah, with that, you know all about the weapon and animations which are triggered once you have the dart weapon inside your hand. Let's have a look at how can we implement a throwing animation as well very quickly. Just a very quick disclaimer. This section looks like it's interactive, but it's not meant to be. It's just an overview how you could actually do something. So please don't touch your code anymore. It looks perfectly. And just make sure you follow me here, but you don't change anything in your code anymore. One more thing we need to consider is that everything we implemented is working extremely well in single player. But for multiplayer, it wouldn't look that cool. So that's also one thing where you will use the fake it principle, because, for example, when you have the physics handle, you will have your dart actually be picked up and moved around with your player. So if you use the faking instead, you could, for example, add an animation, which is looking like this, so a throwing animation, and then the dart would actually being thrown from your hand and not just as it would look currently. If we go to another player's perspective, the dart would just appear in front of the player's face, and then it would just be thrown without moving the hand from his perspective. And that's not pretty cool. So let's quickly change that, and we can do that by going into our content drawer. I already added an animation here, but we don't need that. Pause, delete. All right. And how can we do that now? So if we go to content, living room, blueprints, living room character, you can see we already have a dart in our hand. I just added it for you. And let's quickly show you how you can do that. It's also moving with the animation of the character, and that's quite easy to do once you know how it's done. If you try to do that manually, you basically have no chance. But if you go to the first person mesh here, we've already seen that we have certain bones in here, and I can add a component now. So for example, in my case, I added a static mesh. And then I use the static mesh to be set to a dart. And now you can see this is where the dart is located. And now I can quickly parent that by picking the parent socket here. And for example, let's parent it to the upper arm right, and that would just be how it would look like. And now the dart is moving with this bone together. But of course, that's not what we want in here. And I also changed that for the dart. So you can see I just parented it to thumb 01 right. And if I just get rid of that, you can see the dart is actually positioned here if it's not parented to this bone socket here. So let's quickly redo that. Simply go onto the magnifying glass here, and then you can just go down and pick thumb 01R, and then it looks like the player has it actually in his hand, which looks, in my opinion, pretty good. So that would be how I imagine how someone holds a dart. Of course, it's not like you actually hold a dart, but it's just because I didn't want to change the fingers in here. So it just looks normally. The big question is now, how can we add an animation to that? And that's also pretty easy. If we go to our first person mesh, we can see we have our BPA living room character animation class here. And when I go now into our content folder and then into the interactive media darts folder, you can see here is my living room character BPA. And from there, we have all the animations mapped to this specific skeletal mesh. We can now go with the run forward part here. And this run forward part would be the animation which would be played, but we just want to use its asset. So we go on to create asset up here. We go on to create animation. Then we take current animation and animation data, and we want to save that in our darts folder, and it should be called throw. All right. So what we can do now is we can just change the position of those arms. So if we go with clavicle right, for example, and we turn it upwards, like this, for example, let's quickly see how it would look like. So that would be the throwing animation now. Quite a little bit too far, I'd say. Let's do it like this. And let's see what happens. Yep, that's okay. Very poorly animated, I know, but it's just for presentation purposes. And now we can see the big problem is that it's still looping, and we don't want that, of course. So to get rid of all the frames after we just throw it, so I'd say that's the end of the throw here. Let's go with frame. Yeah, 12 is fine, I guess. Then we just remove everything from frame 13 to frame 58. And now we just have this motion here. That's our throwing animation, but it wouldn't be saved at the moment. So if I quickly show you how the preset preview looks like, it still looks like our running animation. And why is this? That's because we haven't set the position of that as a key in here to know where we have to start from. And to do that, we can simply go onto the click to expand toolbar up here and then set a key. And now if we play it, it looks totally the same, but if I show it to you here, wait, here, there's my mesh, all right? And now I show it here. You can see it looks differently. It doesn't look the same anymore as before. Now to see how this throwing animation actually looks on our character, we can go back to our BP living room character. And now instead of the animation mode, use animation blueprint, which uses our locomotion system, we just use an animation asset. And that will be our throw. And you can see that's how it looks like when our character would throw the dart now. The looping is quite annoying, so let's get rid of that and simply play the logic. And that's just how we could throw a dart. Now we just have to make sure that we get rid of this dart, so it just disappears from our vision when you throw it. But that's how we could actually implement the animation. Let's quickly put that back to our animation blueprint because we want, of course, the idle mode as well to be happening. And the dart is already set to be hidden in game, as you can see here. So we just have to adjust his visibility once we actually throw it. So what we do here is when we not inside the physics, because if we do it inside the physics, we actually grab something and we would move it in front of us. So that doesn't work. But that's one more reason why I tell you fake it. It's way easier normally. And when we do that in the faking logic down here, so let's quickly move that to the right a little. So I have a little bit more space here. All right, this point just got missed. Let's do it like this. And now if we have everything here, we just don't set our dart dummy hidden in game, but instead we would go with our dart here to be not hidden in game anymore. So that's the first part. And then the second part is that we have everything on this side. So we set our dart dummy hidden in game again, and that's not what we want, but instead of our dart dummy, we now use our actual dart, and we want it to be hidden in game and get the world transform. And exactly there we want to spawn the dart projectile. But that doesn't work now because we want to have this hidden in game being triggered after a certain time. And that's why we have to move that even further to the right here. So we can add a little delay here and actually play a montage. So let's quickly do that. I think I have to move it even further. So like this. And now we can go with the first person mesh here. Then we can get the play animation option here. And if we now connect it to true, we can select which animation we want to play and if we want to play it looping or not. In our case, we want to play the throw animation, not looping, and then we want to play, so this starts and it would immediately set the dart to be hidden in game. That's not what we want. That's not part of our logic. What we want instead is that we are actually able to wait for a certain amount of time. And now we have to check how long we have to wait. So let's go to the side here. The dart should be thrown, let's say, after, I think at this point is quite good. So 0.23 should be our delay here. And then the dart will be thrown from there. So we get our delay in here. Let's just use a delay. And this delay should be 0.23 in our case. And once this is completed, we want the dart to be hidden in game, and we want to actually throw a dart projectile. So with that, we now have implemented a logic for actually throwing the dart. And we can now go on and try it out in our game. So what's happening here? We still have our hands. You can see if I jump, they play here. And if I now pick up the dart and I throw it, you can see there's a arm moving right through my face. And of course, not everything is set here correctly, but you can see it would now throw the dart this direction. And it would also play the animation as we want the animation to be played. Since it's quite hard to see what's actually happening from the single player's perspective, I just added a third-person camera as well. When I now start the game, you can see I'm able to switch between cameras by pressing the 1 key. So now I can just move around. That's how our player looks like for any other person out there. And it hovers sometimes. That's not that cool, but you won't see it in single player anyway, so it doesn't matter. And then I can just switch it back by pressing the 1 key again. So how did I implement that very quickly? I just went to my living room character. I added a so-called spring arm to my first person mesh. So this is something that keeps a distance from a specific point. I can then vary with the length here, and that just determines how far this camera should be back. In my case, I figured out 200 would work well. And then I just added another camera here. And this camera is parented to this spring arm here. So I'm actually able, once I move my player around, the camera will follow it anytime. And that's just how a third-person camera is implemented. The only thing that's currently missing there is that I have an event added here. So when I press the 1 key here, I will switch between those two. That's called a flip-flop. So when I press the key once, it will do this. When I press it twice, it will do this. Doing it another time will do this again, and so on. So it's basically flipping between those two states every time. So first time, the first-person camera will be set inactive, and the third-person camera will be set to active. And if I press the key again, the third-person camera will become inactive, and the first-person camera will become active again. So that's everything you need to do in there. And then for the spring arm, you can set the actual height and so on by picking the rotation here. And that's how you can determine from where you want to look at your player. And the camera will then keep this angle all the time in your game. So I just figured 10 here, so you can see it from behind. I think that's not bad, but let's test it out. So if I start the playing animation here and I go and pick up my dart, if I now press throw and I quickly switch, you can see there was this throwing animation being played. Because that's the problem here, I can't move the third-person camera because it's, of course, parented with the spring arm. It will always stay in position. I can't move it up and down. So in this case, let's quickly just throw this dart as well, and you can see that's the motion we then have. And that's not correct because we just have an issue here. And that's the dart not being spawned at a position up here, but instead it's spawned on the hand, which already has moved down again due to our switch between the two animation systems. Let's quickly check that. So if we go to the living room character here and we go to the event graph, we just need to switch up the direction here. So we should set the dart hidden in game and should get this set anim instance class after we've destroyed somewhere around here. Let's quickly do that. So we move that aside, move this in here, and then we play our animation. No, actually not here, but after we've set this hidden in game, like this, and then we just set our anim instance class back to what we have before. So we just can assure that this is all working very well. And it's just how you figure out on the play how you can actually make that best work. So let's move this down a little bit further, like this, and I would just go there. And now it looks okay again. And let's try again what happens now. So when we have the third person camera, which of course doesn't have a body, so we can just throw a dart here. And then when we press 1, you can see now we are stuck in that motion up here. And why is this the case? That should be pretty simple because I have forgotten to add something here. Yeah, right, this part. And then we should be able to see what's actually happening. So now the dart should be spawned right above our head. And when we throw it and have a look at the animation, you can see now it works perfectly and we can just throw the dart from our hand. Let's try again from this perspective. Yep, it just plays the animation and the dart will be spawned from our hand here. Cool. The last thing which we need to do as always is check our current project progress, and you can see we finished it. We built up our whole chess party. We also did the C++ console program together, and now we also finished the Dart part. So you know now everything I can tell you, at least in this course, about physics, blueprints, C++, and Unreal Engine C++. Well, that's it. Thanks for your time. I hope you had a lot of fun. I hope you learned a lot. I hope you know now how you can actually trick something. Like being under control is the most important part in game development. If you can't control it, fake it. That's the essential part here. Otherwise, you will have bugs you won't be able to fix very easily because you can't rewrite the physics engine or stuff like that. And yeah, that's just some principles I wanted to show you. I hope you also like the small animation part. That shouldn't be too much into the detail there because I just wanted to show you how quickly you could add an animation as well to your throw, and then it would look as cool as before for the multiplayer. I hope you enjoyed this course, and I have to say once again, thanks for watching. Thanks for your time. Have a nice day. Maybe see you in the next video.